All right, in the last video, we took our car after we had exposed it and added some extensions to the wires and then got that all hooked up to our relay module. But still isn't going to move on its own until we tell these relays when they should open and close. And how we're going to do that is by using a microcontroller. Microcontroller is something that you can write kind of a basic program for, flash that to the memory on this chip. And then when the microcontroller is powered, it basically is able to know when to send electricity out from these connection points, which we call pins on the microcontroller. Those pins can do a lot of other stuff too, like detect when electricity might be coming in. And on this type, we've got digital and analog options. So digital would be 0 or 5 volts, that's high or low, and analog could be anything in between those values, so anything between 0 and 5 volts. Some microcontrollers work at a different logic level than 5 volts. 3.3 volts is real common as well, so you want to make sure that you're paying attention to that. Where we left off with our car looked a little bit like this, where we had the battery pack connected to the normally closed and normally opens with parallel wires running all the way down, and then had connected our steering and drive motors to the common terminals of each pair. What we're going to add now is the wires that will go between the pins on the Arduino and the relay board. The type of pins that we want to use for this particular relay module is going to be a pin to hole type of jumper wire, where it has a receptacle for a pin on one side and then an actual pin sticking out on the other. The pins here will go into the holes on the Arduino, and with this relay module there's pins on the back here which are the control pins, and I'll put the jumper wire over those for the connection. Some relay modules have screw terminals back here, and then using like a pin to pin jumper wire would be more appropriate. So just like with the wire that we added onto the car, the color doesn't really mean anything, but if you've got the choice, you can pick some intentionally here to have it be a little bit more organized. We're going to need a total of 6, and I got 4 green ones, a red one, and a black one. Let's begin with the red and the black. Those are for powering the whole relay module. And if we look closely at the labels on the board here, one of them is labeled G and D for ground. So I'm going to use my black wire to connect to that. It might be D- on some other relay modules. That can go to any of the grounds over here on the Arduino, so they share that common ground. The red one is going to connect to VCC, or voltage common collector. That's the incoming 5 volts that this relay module needs. And I'm going to connect that to the 5 volt pin on the Arduino. That's a regulated voltage power supply there. Now, when the Arduino is powered, it'll give that power over to the relay module as well, and it'll be able to make those electromagnets work. To know whether those electromagnets should be opening or closing in the relays, they need to get a signal on these middle pins. So we have 4 pins in the middle that are left. They're called in1 through in4. And when those pins are high or low, 0 or 5 volts, that's going to tell the relay to open or close. So slip in on our green wires here. Can get a little tight in the middle. The best way to connect these to the Arduino would be to some of the digital pins, because we only need 0 or 5 volts, nothing in between, so won't use the analogs. What number digital pins you connect them to, you have the options of 0 through 13 on the side. I usually try to avoid 0 and 1 because those get used sometimes for communication when we're uploading and downloading code. And I'll just pick a few in the middle here that match up with the ones that are in the code. I used 5, 6, 7, 8. So I'm going to put in 1 to 5 and then just work my way up from there. Okay, so that's connected. Now we got to look at some code to put on here that'll allow us to kind of test and make sure we've wired this the way that we think it should be working. So here I've pulled up the code that we prepared over a couple of different assignments. I'll link to those 2 videos down below. But just to preview one more time, there's a comment at the top mentioning what the name of our variables here refer to. Motor 1 is for the steering motor. Motor 2 is for the driving motor. And above, well, any Arduino code always has 2 required functions, setup function and a loop function. And the way they're written here is kind of like we're declaring what this function is. So the void means it doesn't return any type of variable when it's done running. This is the name of it. Inside the parentheses would be any required inputs. This has none. And then between the opening and closing curly brackets is everything that happens when the void setup runs. Void setup happens exactly once. It'll do everything in there in order. And then void loop will do everything inside its curly brackets, but when it gets to the bottom, it goes back up to the top and repeats forever. Above this, we declared some global variables. So these are different ways that we can refer to number 5. We can use this name, motor 1A, which makes the code a little bit more readable. It also makes it a lot easier to change which pin we've connected that particular relay to later on and not have to change it everywhere it shows up in the code. The int in front, that means what is the type of variable that has this name, and this is short for integer. So these are all just whole numbers. 1, 2, 3, 4, 5, etc. And there's one for each of the 4 relay pins that we've got. We see in void setup that we're declaring what's the mode of those pins. So using one of the pre-built functions that's in the Arduino library or language. Pin mode takes 2 inputs. It needs to know which pin we're talking about. So here I say motor 1A, that means pin 5. And we're saying it's an output. So it's going to send electricity out. It's not trying to listen for any kind of voltage coming in. We do that for all of the pins we're using. We also begin serial communication. So using the begin function from the serial class here, we're going to use this to debug and actually see on the computer what the Arduino thinks it's doing at any given moment. We can compare that to the motion of the motors. So right now in the loop function, I've got a bunch of commented out stuff that I'm going to use as a test routine. I can go ahead and uncomment all these functions by selecting them, right-clicking and saying uncomment. The functions here, notice they're not color-coded like pin mode was. That's because these aren't part of the predefined language of the Arduino software. It doesn't know what that is. These are actually user-defined functions that we wrote down at the bottom of the code here. So below void loop, here's something that looks the same. It has the void at the front. It has a name. It's got parentheses with any required inputs and then opening and closing curly brackets. Whenever we call this function go forward up in our code, like right here, what it's going to do is everything in between the curly brackets down here where we define what go forward means. And what it does is tells us on our screen with the serial print line function what it thinks it's doing. So we'll see this statement when it gets to this point in the code. And then it makes all those 4 relay pins, the control pins, either 5 volts or 0 volts. That's going to make these either be closed or open, so to speak, with what the switch position is inside those relays. And the different combinations here should make the car motors connect to the battery and move one way or the other. So with go forward, for example, remember that we said motor 1 was for steering. Both of the pins on motor 1 are written high. That means that they're in the same state, and both sides of the steering motor are then going to be connected to their normally closed pins, which is ground in our case. So the steering motor shouldn't move at all. But with motor 2, which was our pair of relays connected to the motor that drives, one of them is high and one of them is low. So one of the relays will be connected to ground, but the other one will be connected to the battery pack on the other side. So current should flow through it and make the motor move. It may go backwards instead of forwards, and that's why we're going to do some debugging here. So we do the exact same thing for this function, go backwards, turn right, turn left, and we have a full stop as well, where everything gets written high again and puts all the relays in their normally closed states. Everything is connected to ground, basically. No current's going to flow. All right, let's look at what our loop is going to be doing then. Take this out. Don't need that right now. It looks like it is going to turn to the right for 4,000 milliseconds. I should point out that was the required input here was an integer, and that integer, which we called go time, is how long it pauses the code in that state. So delay takes an input of milliseconds. So 400 milliseconds is about half a second. I'm going to bump that up so we can look at it for a little bit longer. I'm going to make it 1,000. So it turns right for 1 second, full stop for 1 second. Turns left for, let's make it 1 second, full stop for 1 second. Goes forward, let's also make that full second, comes to a stop, and goes backwards for 1 full second. All right, to get this uploaded to our car, we need to make sure that we've got a USB cable connected to the computer where we were doing the coding and the Arduino. All right, mine's connected there now. And in our code, we're going to go to Tools and double check two things. We always want to do this. Make sure that the board type, the microcontroller, is the one we're using. We're using an Uno, so that checks out. And that we've told the computer which port we're connected to. So you always want to look in there and find the option that says Arduino next to it. And then if it doesn't have the check mark, you need to literally go over and click on it. It looked like ours was okay. So I'm going to go ahead and upload this by hitting the right facing arrow. It'll prompt you to save your code if you haven't already. If there's any mistake, typos here, then it won't upload and we'll get some error messages to help us figure out what we did wrong. So I can hear my car is making some clicks, which is a good sign. And on these relay modules, we can also see there's some LEDs to give us feedback about which relay is firing at any given moment. Very helpful. Looks like there's one about every 2 seconds, which I expect. The car's not moving right now, and that could be because we're not getting power from the batteries. So my car did have an on-off switch. I'm going to go ahead and see if that solves our issue. And it did not. So we're going to do some troubleshooting here to figure out why we're not getting good power from the car. I'm going to pause for a second, hunt around with the multimeter, and then I'll let you know what I find out. All right, it was a pretty easy fix for me. I just hadn't moved the on-off switch all the way over. So I'll move this over. Make sure I push it all the way over this time. We can see the motors are working. Looks like it goes forwards and backwards, turns left and right. Went forwards first, backwards, left, right. Forwards, backwards, left, right. So I'm going to check that combination, forwards, backwards, left, right, against my code to see if that's what I was expecting it to do. So it went forwards before it went backwards, and then it went left, right, and it should have gone right, left. So I actually have this switched around. I had go forwards and go backwards mixed up, and I'm sorry, I had go forwards and go backwards correctly wired with the way it was defined in the code, but right and left I had switched around. So there's a number of ways we can change this. Easy fixes, some of them a little bit more involved. For one solution would be to go over to our relay terminal, find which pair of relays controls the steering motor, take out the wire motors, motor wires, and then switch them around. Just put them in the opposite relays. That's one thing we could do. We could also look at the control pins. So which of these is supposed to be controlling the steering motor? In my code, I just kind of look at my comments at the top here and see that steering was motor 1. So I could look at pins 5 and 6. I could also just switch those around. So take out pin 5 and 6 and switch their position. That would be a solution, a real mechanical one. Another option for fixing it would be just change the code. We could say 6 here and 5 there. That's basically doing the same thing as we did before. And if I didn't want to do that, I could even go down to my definitions of turn right, turn left. Find those down at the bottom here. And switch around which of the relays is high and which is low. So I could make this high, low, and low, high. So that's about 5 different solutions you can apply to troubleshoot this and get it to work. I think the easiest one for me will be to switch around these pins on the Arduino right now. That way I don't need to re-upload my code, which seems a little bit quicker. Awesome. And one other thing I'm going to show here is how we can use the serial communication to also debug this. Makes it a little bit easier sometimes to figure out what's going on. But let's just see if we now get the operation that we expected. Just to refresh my memory, we should see right, left, forwards, backwards. Right, left, forwards, backwards. Plug it in now and see if it's doing that. Ah, classic. I made it worse instead of better. So it looks like pins 5 and 6 were actually for the driving motor instead of the steering motor, is what I did wrong there. And I have the relays in their pairs kind of mixed up, because what I saw there when I plugged it in is that it was going backwards instead of forwards now first, when it should go forwards instead of backwards. So I switched these instead of these around. So let me put these 2 pins back in the order that they were at on the breadboard, but I'm going to swap them with 7 and 8 and put 7 and 8 in 5 and 6. That'll basically reassign things correctly. This is good. This is good modeling of troubleshooting, figuring out what's going on here. Okay, so putting 5 and 6 back in the order that they were in. But now swapping them with 7 and 8. Okay, let's plug that back in and see if that changes it. Again, it should go right, left, forwards, backwards. Right, left, backwards, forwards. All right, we're getting close. So I know what I did there. I'm not seeing my left and right correctly. I had switched around the steering motors again, so I got to switch 7 and 8. Because those are actually for the driving motor. Okay, right, left, forwards, yes, backwards, yes. All right, finally we got it worked out there, and so it matches up with what the code says it should be doing, right, left, forwards, backwards. One last thing I'll show for prototyping purposes was to use the serial monitor. It's a great way to see what the code thinks it's doing at any given moment. And we didn't use it there at all. We just kind of looked at where the code began and where it ended up. But when you have the Arduino connected, you can click on the magnifying glass there. And because we put in those serial print lines, this will tell us at each instant what it's trying to do, and we can compare that to the actual motion of the motors. Very helpful in determining what might be wrong. So if we'd used this right away, I would have seen that when it said it was trying to go left and right, it was actually trying to go backwards and forwards. Probably would have caught that mistake a little bit quicker. Great, but we got it figured out, so that's good to go. We're going to make some quick changes to the code at the beginning of the next video, so this is more useful for actually driving a car. The user-defined functions right now aren't very useful, because when it steers, it's not driving. And to actually get a car to make a turn, it has to steer and drive at the same time.